Good morning, friends. Today we will continue with the shape of the molecules which we learned yesterday. Today I am going to discuss about sp3d, sp3d2 and sp3d3 hybridization. So let's continue with the video. First we will deal with the sp3d hybridization, and I am taking the example PCl5. Okay. Uh, as we learned yesterday, let's take the surrounding molecules 5 plus half of the valence electrons in phosphorus is 5, and we subtract the monovalent chlorine, 5 chlorine. So we get 5 the answer, and it's 5 bond pairs, and the hybridization is sp3d, which is the shape of the molecule will be trigonal bipyramidal. And another example SF4, where we go the same pattern, surrounding fluorine 4 fluorines plus half of the valence of sulfur is 6 minus the 4 surrounding monovalent fluorine atoms. In here, in this case, when we do the process calculations, it will be 4 bond pairs and 1 lone pairs. And hybridization will be the same sp3, and the shape of the molecule will be distorted trigonal pyramid. This is because of the presence of the lone pair electrons, it will affect the structure and got some distortion. And the important example in this category is ClF3. Here also the same procedure we are following, and the surrounding atoms, the same equation, 3 plus half of the valence in chlorine minus the 3 monovalent fluorine atoms. So this is the answer we are getting, 3 plus 2, 3 bond pairs and 2 lone pairs, and the hybridization is sp3d with the T-shaped. See, this is very important molecule which is asked in many competitive examination. Either finding the number of lone pairs or bond pairs or even the shape, this is very, very important. And the next thing we are dealing is sp3d2 hybridization. I'm sorry, there is a slight change in this. Okay. Simple example, SF6. The same principle which we followed in earlier examples are doing in this case also. 6 plus 6 surrounding fluorine atoms plus half of the valence of sulfur, valence electrons in sulfur minus the 6 monovalent fluorine atoms. We get 6 bond pairs, and the hybridization sp3d3, which the heading octahedral, perfect octahedral. And another example in this category is, IF7, iodine pentafluoride. The same equation we are following here, 5 plus half of the valence electron in iodine is 7 minus the 5 surrounding monovalent fluorine atoms, which gives 5 plus 1 6 with 5 bond pairs and 1 lone pair. Hybridization is sp3d2, and the shape of this molecule will be square pyramid. And another example, XeO4. Here also the surrounding is 5 plus half of xenon having 8 electrons in it, valence shell, minus 4 monovalent fluorine plus 1 bivalent oxygen. So the total is 6. Then we do the calculation, we will get 5 plus 1, 5 bond pairs and 1 lone pair electron. The total is 6. So sp3d2 will be the hybridization with the square pyramidal structure due to distortion of that 1 lone pair electron. The shape of this geometry of these molecules will discuss in later in detail. So the next thing in the category is XCF4. The same concept is following here also. If you go through this calculation, you can understand it. That is for the surrounding 4 fluorine atoms plus half of 8 valence electrons from the xenon minus 4 monovalent fluorine atoms. We will get the calculation of 6, and the hybridization is sp3d2, and the geometry is planar. So the one thing which is you need to take consideration is that all the geometry of the molecules are different due to the presence of lone pairs. So that's the factor which you have to follow. And the final thing is sp3d3, and here also I am taking one example only, IF7. The same calculation we are following, 7 plus half of 7 minus 7, that is valence electron in iodine minus 7 fluorine atoms. We will get 7 bond pairs, and hybridization will be sp3d3. Pentagonal bipyramidal is the structure. Okay, so this is about the introduction of shape of the molecule, which we discussed yesterday, and the later we will discuss about other the shape and geometry of the molecules in detail, with the structures and all, which will be explained in detail. Anyway, thank you